So far we have discussed about what is cloud and so the domains of cloud, and then we have discussed about service models. Okay, there are various service models, IaaS, PaaS, and SaaS, and we have discussed what is SaaS, PaaS, and IaaS. So, and we have discussed about deployment models also, public cloud, private cloud, and hybrid cloud. Under deployment models, public cloud where we can pay as per our usage, and is not a expensive thing actually, because all software, hardware, and applications are maintained by the provider itself. Okay, as a user, we simply consume the services. Okay, for private cloud, basically all these services, firewalls are hosted at the vendor premises. Okay, so private cloud always gives control over what their data have. Okay, for suppose if you are working for a Wipro employee data would be there. This data they don't want to place in a cloud, public cloud, because it's a secure data. So they can enable firewall and they can have a dedicated access to this database. That means the company will have the direct control over their data. But we simply use the architecture. That means infrastructure only we use. Okay. So coming to the hybrid cloud, as we discussed yesterday, we can implement both private and public cloud under a hybrid cloud. Okay. So yeah, service providers and all we have discussed. Let me know if you have any questions in cloud, basic fundamental things. What is cloud first of all? Okay. So cloud is a on-demand service where what we can do, we can access the resources like compute, storage, network, and applications through cloud technologies. So through what is cloud technologies here? Cloud technologies is nothing but a virtualization. Okay. One of the technology is called actually hypervisor. Hypervisor. Okay. Hypervisor is a technology most of the nowadays most of the cloud platforms are leveraging. Okay. What is hypervisor? What is hypervisor? Okay, I will show you one simple example. Okay. So what is host basically? What is host? Any idea? What is a what is a server? What is server? Yeah.
It is in connection.
Okay.
Network.
It is it is like a server only. Okay, what is a server? I mean, it is like CPU only. What is the CPU consists of basically? CPU consists of first
RAM.
Hardware. Okay, hardware.
RAM, ROM.
Yeah. Hardware. All the applications are hosted on a hardware. Okay, all the applications are hosted on a hardware. So this is operating system. Okay, you can say this is a operating system. Okay, on top of it actually, okay, we have so many applications. Like this is a one application, and this is another application, and so on. Okay, so this is application one. You can simply say this is app one. App one. Okay, this is app two. Okay, this is app two. App two or okay, app two. Okay, here along with that, we have other hardware components like RAM and then ROM. Okay, and a hard disk. There's another thing called a hard disk. Okay, this is a hard disk. Okay, clear. So what is the configuration of server? What is the main difference between personal laptop or personal desktop or server? Yeah.
Server is connected between.
Server basically the RAM size. Okay, RAM size varies from a 16 GB to up to 64 GB. It's more than that actually, greater than 64 GB. Okay, and it allows multiple users. Multiple users can access.
Yes.
Correct. And third
Yes,
thing
sir.
is actually the hard disk drive. HDD drive is in terabytes. Okay, and processor also very different. Okay, the processor or processing capacity is more than ordinary PCs. The thing is here a very important thing, multiple users. That means it basically does not generate any program, but it allows us multiple users to access. That means it allows inbound processing. Inbound, okay? It allows inbound processing. Okay. So when it comes to a server, okay. So app 1, app 2, app n, so many apps are there. Okay, I'm a user here. I'm a user. So this guy is a user 1. Okay, user 2. Okay, and then user 3. Okay, so user 1 want to access application AP1. Okay, AP1. So how he's going to hit actually? He's going to hit through his URL, and he will hit and get the URL of the app 1, and he will start accessing it. Similarly, user 2, he want to access app 2. Okay, user 3 is going to use some another resource called a hardware component called a RAM or a ROM. Okay, that means at a time all the users are not using all the resources of the server. Okay, user 1 he only access app 1, user 2 access only app 2, and user 3 currently he is storing something into the hardware. That means what it means actually. So at a time we are not going to consume these resources. So through hypervisor, there's a technology called hypervisor. Okay, so the technology called hypervisor, what we can do, we can hypervisor. This is a just assume this is a hypervisor. We can share these resources. And enable to access by the end users. Okay, how we are going to enable actually through virtualization. Through virtualization, we can enable users to access these components. Is it clear?
Yes,
Yeah.
sir.
So basically, cloud is nothing but providing a virtualization of various computing, storage, and access capabilities of the system. Okay. So far, we have learned availability zones and regions. Regions are nothing but geographical locations on the globe. And what about availability zones? Availability zones are nothing but data centers where we have servers and where we have so many applications hosted. So at the end of the day, as an end user, we can access these servers anywhere in the world. How that is possible? That is possible because these availability zones are interconnected. For example, you are in US. In US, what happens? So many availability zones are there. All these zones are interconnected. Even though one data center is down, you can still able to access your application. The reason is actually the same copy of your application is running on some different availability zone. Okay, that makes your application up and running always. Okay, similarly, these kind of servers basically hosted in availability zones. As an end user, what you are going to do with our own account, we are going to log into the database servers. Okay, that means data centers. We can able to access our systems. But when it comes to accessing, how we are going to connect basically, how we are going to connect cloud basically, you tell me. See, you are a user here. You are a user. Okay. your user, as a user, what you are going to do, you are going to have a internet connectivity. Okay, you have internet connectivity. So through internet connectivity, as an end user, what you are going to do, first you will connect to internet connectivity. Through internet, we are just hitting, okay, data as servers. Okay, we are hitting a cloud. We are hitting a, okay, data centers. Okay, so this is actually, just assume this is a region 1. Okay, region 1. Okay, you are in a Asia Pacific. Okay, Mumbai. Just assume this is a region, one of the region. In this region, just assume Asia Pacific has so many availability zones. So in this availability zone, this is availability zone 1, and this is availability zone 2, and this is another availability zone 3. Just assume there are 3 availability zones. Okay. In turn, through, as a user, you connect to the internet. Through internet, we can able to access these availability zones. Once it actually, based on the availability zone, it will connect. Based on the availability zone which you have chosen for your application, it will connect. So it will divert from here to, from here to here. Okay, it will connect the station from here to, it hit this availability zone. Inside availability zone, we have instances running. One of the instances, this is instance 1. Okay, the instance 1. This is instance 1, and this is instance 2. This is instance 1, and this is instance 2, and so on. From here again, we are just hitting the server. Okay, we are just hitting, okay, what you call, from here we are just going here. We are not sure. It will drag. Okay, yeah. So basically, from here, first we hit this availability zone. After availability zone, if we hit the availability zone, in turn we are going to connect to the particular instance. It is available in EC2 stage. But here the thing is, actually we need to understand few networking concepts. Why we need to understand networking concepts? Okay, everything in the world is connected with this IP address, right? Okay, correct? Are you agree?
Yes, sir.
Yeah. So just assume. Okay. Yeah. There are 2 systems available. Just assume there are 2 systems. This is system 1. This is system 2. Okay. So how to connect system 1 with system 2? You tell me. This is system A. Okay. And this is system B. Okay. This is system B. How do you connect?
Through server.
The server. Okay. Okay. To connect these systems, actually, what we need, we need a router. Yeah, we need a router. Okay. Router. Okay. This router basically has a source and destination details. Okay. It basically routes your request to the system A and system B. This is how it looks like. Okay. This is how it looks like basically. Hope you are clear. Yeah.
Yes, sir.
Something like this. Okay. So on top of it, system A has an IP address. Okay. IP address, CtrlZ. IP address. Okay. just something like 172 dot, okay, 172 dot 10 dot 12 dot 23 something. Okay, so this is IP address. Okay, so Control C and just enter one more IP address for this. This is 172 dot 11 dot okay 23 dot 22 21. Okay, see how we are going to identify actually. How we are going to identify the systems get identified through IP addresses only, but the request and response. Okay, request and response. Okay, something like this it will be. Okay. It will be something like this. Okay, exactly this is how it looks like. So the data, whatever the data we are going to access, basically how we is going to access, So through router only we can able to access the systems. We can able to access the system. For example, you are working in some TCS company. TCS have so many networks, right? HR have a different network. Okay, Bangalore DC has a different network. Okay, how that is possible? Basically, we follow a one single network called LAN. Okay, we follow a single network called LAN only. Okay, we call it a big network called LAN. Okay, LAN. In this one, we can simply say this is a LAN. Inside this LAN, actually, we have so many sub networks. This is actually subnets. Okay, subnet 1, subnet 2, okay, subnet 3. Okay.
Okay.
Yeah. Okay. So this is actually a LAN or a local area network. Okay. This is LAN. Okay. So inside this LAN, this is a wide area network actually. It's actually, you can simply say LAN. Inside this LAN, we have subnet 1. Okay. Subnet 1, subnet 2, subnet 3. This is subnet 1. Okay. And okay. This is subnet 2. Subnet 2. Okay. And this is subnet 3. This is subnet 3. Okay. Subnet 3. So when we are going to discuss about VPC in a cloud, Amazon, at that time we'll discuss about subnets. But currently, just look at here, this networking concept, especially the IP configuration details, we have to understand. See, this IP address always, addressing starts with the exponential value of 2. Exponential value of 2 means 2, okay, 2, 4, okay, 4, 8, 16, 16, and so on. Okay. For example, I have two systems. Take the same example of two systems. We have two systems basically. In these two systems, what I want to do, how many IP addresses are required? Tell me how many IP addresses are required for this. Quickly, how many IP addresses are required? How many IP addresses are required? I want IP address for a system A. That means I need one. Correct?
IP4 and IP6 will be there.
Okay. We need how to write actually. Right. There's no right. Okay. I have one IP address. Okay. I will change the color better. Yeah. Okay. This is one IP address. This is the second one. Okay. So router is the right. Router also a component, hardware and software component. And so this also consumes another IP address. What is that actually? 3. That means total I need 1, 2, 3. Is that so? Yeah. But this entire system A, system B, and router are inside another network. Then only we can connect, right? End user. As an end user, I want to connect to system A. How to connect? I want to connect from outside. From outside, I will connect it to the router. Through router only, I can connect to the system. Clear? Yes or no? Okay.
Yes, sir.
That means this is a network basically. This is a network. Please remember, this is a network. Okay. Network. So if it is a network, the network itself consumes 2 IP addresses. Okay, is it clear? So the network itself consumes 2 IP addresses. So how many IP addresses are required now? 1, 2, 3, 4, 5.
6.
5, 4, 5. Okay, 3, 4, 5. Okay. So we need 3, 4. Okay, 4, comma, 5. Right. Now tell me how many IP addresses are required to have this system, to have this architecture in place. How many IP addresses are required? Otherwise, you can say total number of IP addresses which is required to create this infra. There are 2 systems with one router inside one network. Tell me how many IP addresses are required?
Totally 5, sir. 1 server. 2.
Yeah.
I think 4, sir.
4. Sure.
Yes.
Okay.
One is for server here.
Okay.
Another one is for server 2.
Okay.
Third one is for router.
Okay.
And network also one IP address.
Okay.
Totally 4, sir.
4. So system 1 is required, system 2 is required, router required 3. Router also required IP address, right?
Yes.
Router is a hardware component only, hardware and software combination of. See, how you are going to access the internet inside the house?
Through router and
Through router, right? Okay. Is it a router is a hardware or software component?
it is a combination of both, sir.
See, router has antennas and all, right? That means the hardware component. Inside that we have software running anyway. So router also required an IP address. Okay.
Yes.
Now fine. Okay.
And network also we have to connect through IP addresses only.
Okay.
So in that they want one IP address.
Okay.
Totally 4.
Okay. Sure.
Yes, sir.
So what is the rule we have discussed at the beginning? So if you want to provide an IP addresses, it should always the exponential of 2. That means 2 power 1, 2 power 2, 2 power 3, 10 2 power 4. Then how many IP addresses would be there to create this infra?
4.
4. If you allocate only 4, that is not sufficient because network consumes 2 IP addresses. Right? Yeah. Now tell me. The network itself consumes 5 IP addresses. Then can you allocate 6 addresses? Can you allocate 6 addresses? No, that is not possible because 2 power 4, 2 power 3 basically gives 8. There is no 6. 2 power 2, it gives 4. Then can you allocate 7? No, that is also not possible. Then we can allocate 2 power 3. Okay, 2 power 3. That means total IP addresses that we can allocate to create this infra is 8. Total 8 IP addresses would be there. Clear?
Yes,
Total 8 IP addresses would be there. Okay. So as we discussed, there is a classes of IP address. What are those classes? Okay, what are those classes? Okay, just a second. I have just opened. Is it closed? Yeah. Here you can see we are currently following IPv6 and IPv4. These are the two formats we are following to allocate networks to network. Actually, this is also called as a network classes. So how many classes are there so far? We have 4 classes in a network. Okay, we call actually this is IP addressing. So IP addressing always exponential of 2. So there are 4 classes of IP addresses. What are those classes? IP networking classes. Okay, network classes, you can say network classes. What are those classes? The classes starts with A, class A. Okay, class B and class C. Okay, and class D. Okay, nothing actually. When we have a class A at the time, the computational power is not required. That much okay, usage was not there. That's the reason the total number of IP addresses which provided by the class A is very limited. Later on, they have enhanced to class B, class C, and class D. Okay, so class A basically it follows this kind of thing. Okay, so this is a network part and then host part. Okay, network part it can accommodate up to 16 bytes, and then port part it can go up to 31 bytes. Okay, just assume. Okay, so class B where they have increased that power. Okay, so then coming to class C, basically class B typically assigned to organizations with many hosts on their network. Okay, class B we use for organizations. Class A is basically used for what you call personal purposes. Okay, use the first 8 bits of the IP address as the network port. Typically, class A is used by the personal purpose, personal public purpose. Class B is for organizations. Class C basically the range starts from 192 to 233. The second cover basically starts with 1 to 255. Here you can see the ranges. Class A range 0 to 127, Class B range 128 to 191, and Class C 192 to 223. Network address something like this actually, triple X, Class B XXXX, and then Class C XXXXX. Currently we are using Class D. That is the reason we have XXX dot XXX dot XXX dot X. Okay. So class C can accommodate only 3 digits. That means this is a network address we follow 10 to 127, right? So class B it accommodate 128 to 191 with 2 numbers. Okay. Class C can accommodate 192 to 223. Okay. And class D basically it will give 192 to 256. 256, 2 to the power of 8. Okay. So coming to class A, these are the ranges as we discussed. Okay. So basically why we need to understand here is currently we are using only class D. Class D follows IPv4. Okay, version 4. That follows the maximum IP address under IPv4 is 255.255.255.255. Why we have only 255? Basically our bytes range starts from 0. That is the reason we have only 0 to 255. The total number of IP addresses covered under 0 to 255 is 256 if we include 0. Yes. Okay. So these are the various IP address classes. Okay. Currently we are using IPv4. Okay. Even Amazon also follows IPv4. Okay. Only what do you call networks, Geo and all, they are following VP6, IPv6 format. So this is all about a very high level overview of networking. Okay. Next topic is I just want to explain what is CIDR. What is CIDR? Why we need to understand CIDR? Okay. See, under cloud, we need to understand networking concept. Every device has tagged with the IP address because IP address acts as a address of the device. It might be hardware or software. Okay, we always communicate with these devices through IP addresses only. Okay, there are two IP addresses. One is a public IP address and another is a private IP addresses. Okay, the public IP address. How to find the public IP address? Tell me how to find the public IP address of your system. Okay, just check here. What is my IP address? Okay, so here you can see the public IP address of your system. This is a public IP address of your system, basically. Okay, so when it comes to your private IP address, how to check? CMD IP config. This is a private IP address. This is IPv4 address of your laptop 192.168.29.112. If you want to connect your system laptop internally, then we use this IP address 192.168.129.112. When it comes to internet, okay, when it comes to internet, if you want to connect to this laptop, they have to use IPv4 of 49.37.127.146. Okay, so these are the various formats which we follow: public IP and a private IP. Okay, public IP, that is actually useful to connect to the internet. Private IP, that okay, you are maintaining a private network. Others you don't want to allow it. Okay, then where we use a private subnet. Private subnet will have all the private IP addresses. Okay, coming to CIDR. What is the CIDR? What is the CIDR? Any idea?
No.
Okay, CIDR is nothing but a classless inter-domain routing. Okay, classless inter-domain routing. I've seen already class A, class B, class C, class C, class D. That means if you follow CIDR, we are not following any of these classes. We can use any of the IP address. That means that's a classless. Inter-domain, there are so many subnetworks are there. So these subnet networks can be communicated through CIDR. Okay, so classless inter-domain networking. Okay, what is the notation of CIDR? CIDR basically looks like something like this actually. So we can simply say 49.12.23.25 of okay 29. Okay, so what is this 29? The notation looks like this actually. IP address of X, right? IP address of X. Tell me what it means.
29.
What it means. So the IP address indicates the starting address, and the X is the size actually, subnet mask value. Okay, subnet mask value. So what is the use of the subnet mask value? Why we need to use actually? By using the subnet mask value, we can calculate how many IP addresses which we have allocated. Okay. Okay. So here we need to understand the total number of IP addresses any given network. Any given network should be the power of 2. That is the first and basic fundamental rule. Okay. In the total number of IP address in any given network, okay, should be power of 2. This is the first rule. This is we have to remember. Okay, first rule. Second rule, when it comes to second rule, actually, okay, there should not be any device without a network or without any IP address. Okay, no device. Okay, no device without a IP address. That means if there is any device, definitely it should have an IP address. Okay. So second thing is actually the IP, the network itself consume two IP addresses. Clear? So
Yes,
you
sir.
have to remember all three rules. Okay. So then coming to the router, what is router? A router is basically a physical or a hardware or software device. It will communicates among the systems. Okay. So router also called a switch. Switch or router, one another same. Is it clear? Yeah.
Yeah.
So coming to the, okay, what is a CIDR? When do you use CIDR? Okay, already we have discussed how many IP addresses we can allocate if there are three systems. If there are three systems, how many IP addresses are required? For example, one more system also there. 1, 2, 3, 4, 5. So we can't allocate 5 because it fails first rule. Okay, it fails a first rule. So automatically we have to allocate at least 8 IP addresses. Okay, to create. Okay. Then coming to CIDR, we are discussing about CIDR, right? So Ctrl+S, cloud. What is CIDR? CIDR, as I said, CIDR is nothing but a classless interdomain routing. Okay. This is very useful when you want to calculate how many IP addresses are required. How many IP addresses are required? Okay. What is the maximum IP addresses we can allocate? So 255 dot 255 dot 255. This is the maximum size. Okay. So whenever you are going to create a infrastructure, ideally the IP addresses keep on increases. Okay, like odometer, speedometer in our vehicles. Okay. So if it is a 0.0.0, okay, just assume there is another one called here we have 0.0.0.0. Now tell me, what is the maximum size of IP addresses in between this IP address and this IP address? Quickly.
0 to 255.
Okay. How many are there?
256.
Come on. 0, 0, 0, 0. 255, 255, 255, 250. Sorry, it's also 255 basically. Okay, it's a 255. Gestation is a 255. Now tell me. It is equivalent to, I told you already, 255 into 255 into, okay, into, yes, okay, into 255 into 255. This is the value. Okay, it is almost like how many values? 255 into 255 and 255. I think 430 crore IP address. Okay, so calculator. We have calculated also this one. Okay,
Yes.
255 into 255
into
into I don't have this one. Yeah, into 255 into 255. This is the value. Okay. So, but we have calculated wrongly. Why? We are not considering 0. If you consider 0, we have to take 256. At that time, you might get, I think, 430 crore, almost 430 crore IP addresses are available in this range. Is it clear now?
Yes, sir.
430 approximately. Okay, crore IP addresses are there. Okay, now tell me, this is an IP address. This is an IP address. Here we have 172 dot, okay, 20 dot 10 dot, okay, 0 0. Okay, there is another IP address 172.20.10. Okay, 11 dot. Okay, 10. Tell me how many IP addresses are there?
172 into
172.20.10.00 is the first IP address, and there is another device in the same network, 172.20.11.10. This is the last device in our network. Then how many IP addresses are there in between?
addresses.
How many?
8, sir.
256 plus 10. So equal to 266. Correct? It starts with 0. Once it reaches 256, automatically 10 will become 11. Got it? See, it is 10.00. Okay. It keep on increases 0, 0, 0, 1, 0, 2, 0, 3, 0, 5, 0, 6, 0, 7, and then finally it reaches 255. Okay. From 0 to 255, we have 256. On top of it, how many are there again? Again, start with 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So another 10. So automatically we'll have 255 plus 10, 256. Clear?
No, sir. No, sir. I'm confused.
See, you are riding a bicycle, okay, motor vehicle. Okay, in your two-wheeler, currently it is showing 10 kilometers. Okay, after that, after you driving one more kilometer, it will become 11, right?
Yes.
So meanwhile, what it will do? 10.01, 02, 03, and all it will keep on increases the, okay, that spindle. Correct. But in IP addresses, what is the maximum value it reaches? What is the maximum value it reaches in IP addresses? 255 is the maximum value. So 0 to 255, how many values? What are the, how many values are in between 0 to 255?
256.
256? Yes. After that, after reaching 11, what did happen? It starts with 0 again. 0, 1, 2, 3, 4, 5, and so on. 10. Then it will become how many? 256 plus 10. 266 IP addresses are there. Clear?
Okay.
Now?
Yes.
Okay. So coming to CIDR, why we need to learn CIDR? Okay, this is the same format you have to follow. Please remember this technique. Okay, this technique you have to remember. Okay. So ideally, if you give, I will give one more example. There's another IP address. Okay, here 0.0.0.0. Okay. So 0.0.0. Okay. 56. Now tell me how many IP addresses are there?
0.0.
Yeah, how many IP addresses are there?
0.0.0.57.
Yes. Okay. Total 57 IP address because it starts with 0. 0, 1, 2, 3, 4, 5, 6, 7. If you include 0, we get around 57 IP addresses. Clear? So the maximum value of the port or IP address is actually it starts with a 0 to 255. Please remember this rule. Okay, 0 to 255. This is the range. Hope you are clear now. Yeah.
Yes.
So you have to remember this always. Then coming to, for example, I am giving one more thing. Okay, 0 to 0 to, sorry. So wait, dot 0 to 0 dot. Okay, 255 this time. 255. 2, I'm giving a, okay, 0.0.1.0. Now tell me how many IP addresses are there? It already reached 255. right? It already reached 255. The next one is only one, hence it will have a IP address
255.
called only one IP address. In between, how many IP addresses are there? Only one IP address. Clear? 0.0.0.255. We have already reached the maximum length 255. Then immediately it will go to the next 1.0. Then we have only one IP address. Okay. So tomorrow we'll discuss CIDR. Okay, we stop here. Then we'll catch up tomorrow.
Sure.
Let me know if you have any questions.